Good day everyone, I'm Marjan and gonna present this project on behalf of the team. Aim of the project was to improve the external thermal comfort on Nelspruit University campus in South Africa. In this presentation, the comfort assessments by computational simulation and in-situ measurement have been proposed for different design stages. The focus of this talk is about thermal comfort in outdoor spaces. As the impact of the environmental parameters, the level of human body thermal condition varies from extreme cold to extreme heat, and this spectrum is divided into 10 categories to represent the different thermal stresses by ETSAC criteria. Let's start with measurement. The usage of measurement starts from the very early stages of the design when we need to learn about the context and built environment. The lessons learned from this stage can significantly improve the design to respond to the context. Radiant ambient imaging, RAY method, is used here to capture the most critical parameter, mean radiant temperature, MOT, and calculate the radiation flux from each surface, while other parameters are recorded by other sensors simultaneously, such as airflow, humidity, and air temperature. For the setup, a camera is placed on top of the silver hemisphere to capture the context. As you can see, the view field of the hemisphere gets wider when the camera distance is higher. This allows us to be able to almost capture everything. After capturing a series of photos and image post-processing, we can map the ambient radiation and see the share of each surface to the total MRT. In the image-based process, each pixel value represents a series of data that allows us to determine different variables from the vector direction to the wavelengths and finally, radiation flux density. The RAY method is used to assess the already built areas like the provided shade in this courtyard, which is designed to mitigate the heat stress. The result shows the radiation flux from each direction. A significant portion comes from the canopy itself as a line of radiation. It is possible to divide the directions into a series of numbers and assess them individually or as a total MRT. As is shown in this diagram, the lowest radiation comes from the area including the sky and highlights the role of the sky to be considered as a cool surface. Surfaces can be assessed individually to indicate the role of each and evaluate the material properties and orientations. In this example, the context is divided into 4 main surfaces to be checked. As is shown, the canopy represents a surface with 45 degrees Celsius with 0.3 view factor. The next part is simulation assessments. North part of the Nelspruit campus is selected to be simulated based on the outdoor comfort to highlight the most effective parameters and critical conditions. Numerous vector is used to simulate the role of each contextual parameter and the total radiation, from long-wave radiation of the urban surfaces and atmosphere to the short-wave from the sun and its reflections. A series of analysis and calculations are executed in parallel to achieve the other parameters beside MRT to be overlaid by ETSAC criteria. In result, heat maps can be provided to visualize different periods or conditions, such as the probability of occurring slight or moderate heat stress or the impact of reducing direct solar radiation. To simplify the process and make it more digestible, different geometrical morphologies are categorized and assessed separately like canyons, courtyards, and squares. Then these categories are considered in different periods, and the relevant design strategies are suggested and implemented to improve the comfort conditions. Next, the in-situ measurement method has been applied in the final stages of the construction to evaluate the performance of the external spaces and to suggest the required adjustments. The benefit is to compare with the gained information from the simulation and check the proposed rules of thumbs in the earlier stages of the design phase. This comparison provides the chance to recognize the shortages, to adjust the design, and to use the lesson learned for the design of the other developments with the same microclimate condition. The limited amount of measurements were executed when heat stress occurs mostly. The results show that the geometrical orientations and provided shade allow users to choose the more comfortable path and area to pass or stay longer. To conclude, the main purpose of this project is to indicate the benefit of application both of the simulation method and the in situ measurement technique by clarification the advantages of each of them in the design process to improve the thermal comfort in the outdoor spaces. Both methods can be beneficial in different stages of design based on their capabilities in the post-processing section. Thanks for listening. I hope you enjoyed it, and please let us know if you have any questions or comments.